Hi guys, today we'll be doing the experiment on iodination of salicylamide, and here are the things that we will need. We also have labeled diagram for you for your understanding. So there's a stir bar, the round bottom flask, and the air condenser with its related contents. So first things first, first we have to weigh out the salicylamide, which comes in a white powder, like many of our other things. So we'll be weighing out 0.25 grams of salicylamide, something around that. We will transfer the salicylamide into a round bottom flask with a stir bar in it. Next, we will measure 5 ml of ethanol, and we will do this using a mechanical pipette, since we need to be pretty precise about this one. The ethanol we are adding is absolute ethanol.
Then we let the round bottom flask sit on the magnetic stirrer. As you can see, the heat is switched off.
While the salicylamide is being stirred in the round bottom flask along with absolute ethanol, we weigh out around 0.30 grams of sodium iodide powder. And this will be one of the reagents for this reaction. When we come back to our reaction fume hood, by now all the salicylamide has dissolved in absolute ethanol, and we are going to add the sodium iodide that we just weighed out.
Sodium iodide is being added to the round bottom flask containing salicylamide.
Then we are going to dissolve everything in the solution using a glass rod. And then the solution is stirred again using a magnetic stirrer. Attach an air condenser on the round bottom flask and place the flask in an ice water bath so that the solution cools down to about 0 degrees Celsius.
Then we pipette out 9.2 ml of Clorox bleach and quickly add it to our solution in the round bottom flask. While quickly adding the Clorox bleach to the round bottom flask, notice the color change.
The flask was quickly swirled after the addition of bleach.
Then leave the reaction mixture in the round bottom flask on the benchtop for 10 minutes. After resting for 10 minutes, carefully dismantle the condenser.
And then add 2.5 ml of 10% sodium thiosulfate.
Next step is to acidify the solution. We introduce acid into the solution by adding 10% hydrochloride solution dropwise.
The acidity was checked using litmus paper.
Notice the change in color with the addition of hydrochloric acid.
We will also be shaking the flask so that the acid reacts completely.
And after every little addition, we also need to check the acidity by using a litmus paper. The solution should be just acidic. So if everyone remembers correctly, litmus paper turns from blue to red or pink in the presence of an acid. So after one initial dip, you can see that the paper is blue. That means the solution is still alkaline. So more addition of hydrochloric acid,
followed by swirling of the flask, and more intermittent checking with the litmus paper. We keep doing this until the solution is just acidic.
litmus paper is still blue. That means we need more addition. Still no significant pink color. That means more addition of hydrochloric acid. Then after more addition of hydrochloric acid, the solution right now is pretty muddy, and then we'll check again.
This time the litmus paper dipped in the solution comes out pink, which means the solution is acidic. Next, we need to vacuum filter the solution. So our TA Goshu is getting the vacuum filtration setup ready. Switch on the vacuum, drain the mixture as we have seen before. Rinse the flask and the product with cold DI water and then transfer the rinse onto the harsh funnel. After vacuum drying the product for about 5 minutes or so, we transfer the product into a fresh, clean beaker. This product will now be subjected to recrystallization. Recrystallization, we have seen it before. The first step of recrystallization is to dissolve the crude product in a hot solvent until the product just dissolves. In our case, the hot solvent is 95% ethanol. We also stir the product using a glass rod just to make sure that the product dissolves completely and we don't need to add more solvent. So in recrystallization, our goal is always to dissolve the product in as little hot solvent as possible. In this clip, as shown, the crude has dissolved completely in the hot solvent, and now our goal is to move to the next step, which is cooling down the beaker to room temperature and then with ice. After it cools down to room temperature, transfer the beaker into an ice bucket for it to cool more. So after the solution has cooled down enough by resting in the ice bath, we kind of agitate the solution by scratching on the walls of the beaker using a glass rod and enable crystal formation. Then the solution was filtered using vacuum filtration. While the crystals are vacuum drying, we take the mass of an empty vial. When the product has been vacuum dried for about 5 to 10 minutes, we take the harsh funnel and transfer the product from the harsh funnel into the product vial. Then, as usual, we take the mass of the vial with the product in it. So for characterization of this product, we have taken the readings for the mass.
So for characterization of this product, we have taken the mass and we also need to take the IR, and there is no need to take the melting point.
So as we have seen in IR before, we clean the stage, we expand the window, and then we collect the background, and yeah, and then we wait for 8 rounds to complete. Add to a new window, no, for background. Then load our sample.
In such a way so that the little hole is completely covered. Click on Collect Sample, name the sample, and then click OK. And then wait for 8 rounds to complete. For this experiment, you need to look at the wave number region of 700 to 900 in the IR spectrum in order to determine if the iodination has actually occurred.
Add to a new window, yes. Okay. Then find peaks, adjust the horizontal line until you cover all the peaks. Then click print. Then clean the stage using isopropanol.
Once the experiment is done, you throw away your liquid waste in the liquid waste container, solid waste in the solid waste beaker, and then you clean all your glassware, first with an organic solvent like acetone. And once everything is clean, you also then rinse your glassware with distilled water. And yeah, and then you just throw away any broken glass in the broken glass container, and that's it. So that was it, guys. We have completed the experiment on the iodination of salicylamide, and we have taken the mass of the samples, and we have taken the IR spectrum, and the melting point is not needed, so we will not be taking it. So that was it. Thanks. Have a great day.